Microphone check. 1, 2, 1, 2. Does it work? Okay. Audience check. 1, 2, 1, 2. Please raise your hand if you're in the room. Okay. Still, a few people didn't raise their hands. So I guess they're not in the room. Oh, the Monday morning is really hard for us all. Well, anyway, I am glad you made it. I am glad we all made it, right? Yet again for the 20th edition. It was really like a fun and I would say also an honor to see my face in one of these previous editions, right? Yes, but today we are about to talk about test containers, needed, simple, and powerful. It's Monday, of course, so it's going to be a deep dive, which means it's going to be 3 hours, more or less. And spoiler alert, this is an extended version of my other talk called Integration Tests Needed and Simple, right? And just to, of course, like this is a spoiler about test containers. So the thing we're going to use today is going to be test containers. Right. So quickly about myself. This is the thing you ask yourself, I guess, when you take a look at the slide. What the heck is this guy's name? Let me show you something. Yes. So it tells you a lot, I mean, about my motivation for this talk, right? Having this name and using untested software when trying to purchase various tickets or something. So that's also the reason, right? Yes, my name is Piotr Przybyl. I live in Poland. I work from Poland. I'm Polish. I flew in from Poland yesterday. I work as a software gardener. Who knows what software gardener is, this role? Not really. Okay, so there's this fantastic book called Pragmatic Programmer. Okay, I suggest you should read the book. It's really worth it. Not only for this software gardening thingy, but also like for many other reasons. And yes, so I'm self-employed as a software gardener. I got also nominated as one of these test containers community champions. There's like 20 people or something. So I'm very happy to be like in the initial or seed round, if I may say so. I'm also occasionally a trainer or a speaker, just as today, right? So this is what I do. And if you're curious about, like, if you don't like me talking, right? And I promise you, I will do my best. I promised several people already that I will try to speak slowly, okay? But if you think I'm talking too fast, just let me know. Okay, raise your hand. We have 3 hours, so I should speak slowly. But if you prefer me not to talk, but just to listen, to read what I have to say or to pass to you, then you can go to my page softwaregarden.dev. Yes, basically this is me. I realized, and excuse my French, I shit you not. I literally started programming in Java 20 years ago, in October 2003. So I've been with Java behind for like 20 years. It's mostly backend systems. Of course, it's sometimes Scala, sometimes it's Groovy, sometimes it's even like different languages like Golang or whatnot. But usually it's Scala. Usually it's backends. Okay. Sorry, it's Java and backends. See, I'm nervous. I'm saying funny things. The question is, who are you, lovely people? Who is a developer among us? Software engineer? Almost everyone. Someone who's not in software, not an engineer? Okay. Okay, are you managers? Are you QAs? Who are you? Shout, don't be shy. The session's for us. Teacher, perfect. Yeah, I hope I will give you enough material for today. Yes, so who's using Java 21? Come on. Why aren't you at Nikolai's talk? Okay, you should be using Java 21, really. Okay, Java 17. Okay, Java 11. Okay, in Java 8. Oh gosh. And like Java 7 or even older, don't be shy, I don't judge. Okay, I'm sorry for you. So, yes, okay, have some jellies, okay? Like, we always something sweet. Catch it. Oh, sorry, almost. Yes, just spoiling things a little bit. Test containers requires Java 8 or above, right? And I don't expect test containers to be bumped to any new version of Java anytime soon, because because of all of these legacy projects, right? So we need to test them somehow and so on. That's why I think test containers will be like maybe not turning the light off, but one of the very last libraries or frameworks stopping supporting Java 8. Okay, a little warning, okay? Everyone can make mistake. Sorry, I have to like zip my mouth because they're taking lovely pictures. Okay, cool. Yeah, because it's when you're a speaker, you always have a picture like this, like, and it doesn't make much sense, right? A little warning. I speak for myself. I might be misusing test containers. I might say funny things because I'm stressed and I'm like, I don't have Tourette's syndrome, but I have like slip words that don't quite match the context. I realize that. And like, the most important thing, you should be verifying everything on your own, right? So don't trust talking heads if you're watching this on the internet. Also, like maybe try to verify things on your own because it's a human thing to make a mistake, okay? Especially on Monday morning when you're short on caffeine. Okay, let's switch gears now. So as we all know, there was this pesky thing, and actually it's still like between us. It's called COVID, right? So it's the first like like a real I would say post-pandemic thingy, and I hope like we didn't lose too many or any in fact like close people who were close to us, but still we suffer sometimes from it, right? And sometimes we receive these calls from, for example, from your grandmother, or from your auntie, or from your mom, right? Someone saying like, look, my child, I have this gas stove in my kitchen, okay? And I'm afraid I didn't fully recover my smell, okay? Because this COVID thing or something. And I suspect, I'm not quite sure, I suspect sometimes the gas is leaking, okay? So this beautiful lady who loves you, and she gave you a call, because as you just have shown, you're an engineer, right? She calls you and she wants you to do something about it because you're an engineer, okay? Software, hardware, construction, doesn't really matter. You're an engineer. Please come and help, okay? So what do you need to do then? Okay, so what do we need to do? We need a kind of like a gas detector, okay? A device that you can put in this kitchen, like above the gas stove or next to the pipes or wherever, that will ring an alarm, right, and make a sound and maybe lights and whatnot when it detects that there is a gas leaking, okay? This is what you need to do. And so what we're going to do? What we're going to do? As, we're in this industry, so we can basically do two things. First, we can go and buy something that is already there. We can just go to a hardware store, right? Select like talk to a salesperson, get like the device that fits nicely our needs, right? Pay for it, bring it home and install. Or we can do just as we do in software engineering. We can build software on our own, right? Which of course might not be delivered before the initial deadline, but at least it will cost more, right? This is what we do in software engineering, right? So this is what I'm going to do with you, if you don't mind. And for this, I mean, this is going to be like a real experiment, so like a health and safety protocol, okay? We're gonna do some like a proper stuff, okay? So, what do we need to build a gas detector? Come on, people, don't be shy. Flame? No flames today. Sorry. I know you're eager, but there will be no flames today. At least I'm not aware of any. So let me switch gears for a moment because I will be the presentation. I will be the slides for time being. And this is for your convenience, okay? So the first thing you need to have to build anything is, of course, casing. So we have this lovely case, and we'll put more stuff inside. So what is the first thing you need to do, or you need for this box to operate? Sorry? Sensor. Very good. Yes, we need a sensor. So I found it. I have this very nice sensor. It makes this very nice clicky sounds. Where's the mic here? See? It's a very nice sensor. I don't have to test it because I found it from a very trustworthy and certified vendor called SourceForge.net, and it's been proven to be working for years. So why should I test it? Like, let's toss it into the box, okay? But then I need to power it somehow, okay? So I have this nice source of power, okay? It's just I need to verify this power actually works. So how do I verify it? I will use this mock, okay? This lovely fan is my mock. So I don't need it actually in my sensor. I don't need any fans, right? It's not going to overheat. Let me just use this mock to see if I have enough power. Very nice and chilly breeze. I love it. Okay, cool. So we put the power here, okay? Next thing, and let's see if it works because I didn't test it, we need like a speaker, right? Something that will make a sound. Apparently it's not charged, so normally it works, but I see I've forgotten to charge it. But let's disable a test for it and let's toss it into the box anyway, right? And yes, of course, and so what else do we need to complete this box? Yeah, of course, we need wiring. We never go wrong with wiring, right? So we toss some wires, but we also need something that will do this blink, blink, see? And this thing barely blinks. I don't know if camera shows it, right? So just in case like that this thing fails or we need to be like more business-oriented, what are we going to do? More blink, blink, because more blink, blink is obviously better. Right, so in the box, right? Everything goes in the box. Now we can close the box and we can ship it, and it's a very nice box. It has these lovely smiles, right? Lovely green smiles. So it's like we've tested everything. Okay, we disabled one test, but it's just one test. We have everything tested or certified or anything, and I have built for you grannies, a lovely smoke detector. Will you use it? Who wants to use it? And make sure you're not a manager. Because it's always managers where they go, yeah, me, pick me. Right? Nobody wants to use it. But let me ask you this question. Wasn't this smoke detector built the same way we actually build software or test software? Why is it so that suddenly, when we change the hats, okay, when we're no longer just software engineer, working on this fancy page, showing cat memes or whatever, when it comes to the life of people who we really love and care about, then something clicks in our mind, right? And then we see that this approach is a flawed one. And it has no more this fancy, smiling faces, but apparently the reality might be quite sad, right? So let's fall back to the initial approach, which is let's try to get something which is already there. We just need to make sure it will fit our infrastructure, our kitchen, if you will. And just for a short disclaimer, I'll be using a device, but I don't recommend you buying this device. I just needed something for this presentation, okay? So we have this device. They say it's like a smoke or gas detector. It looks like this. And I don't know if the camera can show it to you. Like, come on, focus. Focus. It says, anyway, it says here, push to test. What shall I do? Push the button, baby, of course. Yeah, exactly. Who said that? Okay. For brilliant answers like this, I have this special edition of super extra large Testcontainers stickers, right? I have regular ones for everyone, but for you, please have like an extra size. Yeah, exactly. We tested the sound. Or maybe just like a Soviet scientist. Soviet scientists did this test once that they discovered that there is a direct neural connection between eyes and the bottom, because they stuck a pencil into somebody's eyes and they made their pants dirty. Okay? So we know there's connection between this button and the sound and the speaker. The question is, let's picture this. It's 2 a.m. or 3 a.m. Everyone is asleep. Your auntie is asleep. And then the gas starts to leak. Do you really think that the gas will go, oh my, I mean, I have to be a gentleman. I have to go to the kitchen and push the button so the lady will wake up. Is this how it works? Not really, no. I mean, unless you're a Scrum Master, but that's okay. That's another story. So, let me do something that I believe we should be doing. Before you install this actual thing, what do? We take this thing, we put it, like as the name of the talk may imply, we put it into a container, okay? And then what we do, we seal the container. Let me seal it because safety protocols. Right. Let me open this valve. Okay, and then let's put some extra level of safety or security, if you will, right? Because we need to make sure nothing leaks. And now, what I'm going to do is I'm going to intoxicate the atmosphere inside. Okay, so let's see. It might not work, you know. These tests can be flaky. Let's see. And let's wait, you know. Builds take time. Integration tests take time. You know, you have to, like, make sure. Come on. Are you working? Aren't you working? Do we need more gas? Come on. You're ruining my demo. Maybe they need, oh.
Carbon monoxide gas leaking. Please open the window and the door. Attention, please.
Apparently it worked. Right? So we have this integration test running. Yeah, let me stop the build because it will be too much annoying. Okay. Yes, let's put everything in this bag. Let's make sure it's sealed. And now let me ask you this question, lovely people. Would you rather install this thing or this thing? Who votes for this? And who votes for this? Again, not a single hand. So why do we build and test our software like this, not like this? What's the freaking difference, right? And we still like maintain those marks and whatnot. Okay, I might not be needed anymore. Okay. Yes, that was it. That was the live experiment. So our talk will continue. So sometimes what you need to have to make sure that your stuff is already or working actually as it should be, where's my clicker? Here, is Chad. And you don't get the joke, obviously, because you're not Polish. In Polish, Chad is a common name for carbon monoxide. You need this gas to actually trigger the thing to see if it's working, if it's really, like once you hook it into power, that it really does what it should be doing, okay? This is what you need, okay, or who you need. So, my friends, I'm afraid that the question is not, will this code will be tested when it comes to testing code, okay? The question is, who will test it? When it will be tested? And how much will it cost in general? That's the question. Because I think that every code will be tested, right? Eventually, everything will be tested, in the worst case, by our users, okay? So this shift-left paradigm is not maybe just like, you know, like a mambo jumbo or like, I don't know, people taking pictures. I love that you take pictures of this slide, really. It makes me happy. Every piece of code, every integration, unless it's a dead code, of course, will be tested. In the worst case, in production, and people will call you or stop their subscriptions or whatnot, right? So the real thing is to test it ASAP or test it before they see it, before we break things in production. And of course, we are not able, let's be pragmatic for a moment. We are not able to test everything, right? That's why we have feature flags. For example, we need to switch because good luck testing people's behavior. or they test, do they prefer like this color scheme or this color scheme, right? And this is the only thing you can do when it comes to testing with people, like at large scale, and you need feature flags. And of course, when you are truly agile, when you're not doing agile, but when you are agile, you know that there's only one thing that's constant in this industry, and that's change. Okay, things are going to change. So sometimes we have to go fast and so on and so on, but still, I believe we should test things before stuff happens in production. So this brings us without question into this discussion, what is actually the shape of our testing suite, or what should it be? And if you paid attention to the initial slide, there was like a pyramid in the clouds, only it was upside down, right? So these are the shapes we can possibly have, some people say. So this is the shape of the why isn't it working? Hold on, let me check. It should be working. See, it's not. Because it would be easier for us. Sorry, see? Does it work now? Yes, perfect. So people say it should be a shape of a pyramid. Right? So we have unit tests in the bottom, then we have some integration tests, then we have like some stress tests, like with Gatling, then we have like E2E tests, and then manual tests and whatnot. Okay? And some people say maybe it's not the right shape. Because let me ask you this question. When did we build pyramids as a humankind? 4-5 million years ago, like 5,000 years ago, okay? And at the time, it was a masterpiece, okay? People in Egypt were building pyramids, in Mesopotamia, in Mesoamerica, right? Because it was like a perfect shape. And actually, sorry, I don't care if it was like a launch pad for aliens or not. Really, it's not about that, okay? It's like at that time we thought this is a very nice like shape, okay? And these days, what you have? We have like the little pyramid like in front of Le Louvre. In Paris, right? We have like maybe a casino in Vegas, and maybe some fancy people who absorb cosmic energy also live in pyramids. But that's pretty much it. Do you live in pyramid? Do you have a pyramid in your yard? See? That's what I mean. So why do we still use the term testing pyramid if this shape of testing suite, right, was invented in the time when our systems looked quite different? When the systems were deployed not like in a cloud, but in the big machines, like occupying half the floor. And if you were lucky, they had like magnetic tape or a hard drive. If you were unlucky, they had still like punch cards, okay? So this is the time when the testing pyramid was coined. And maybe like a few centuries have passed since then, in terms of IT, of course. Okay? So maybe this is not the right shape. So some people say, yeah, of course, this is not the shape. We should go for this honeycomb. So these are like unit, and here we have like E2E tests, and here we have, for example, integration tests, and this should be like the thing you're using the most. And some people say, no, we should go for the trophy shape, or like a Pokal shape, they call it in German, right? So this is like, imagine this like this trophy shape, or something, right? Sorry, I made this drawing on myself, okay? I don't have like the whole graphic designer department at my will. Okay, I'm not a professional developer person, so you have to stick with my drawings. Okay, this already shows you I'm a backend engineer. Yeah, so these are possible shapes that people are arguing that our testing suits should look like this, and maybe they should look different, right? Maybe we should reverse the pyramid. Maybe we should put it upside down, right? Or maybe we should put the Pokal upside down. Or maybe our test should be like peer, with these things like standing out. Or I don't know. I really don't know. Because I would say how you test your system depends on your system, and I'm not in your shoes, right? And I can't tell you, I can't give you an advice. I'm not a life coach, like drink 2 or 5 liters of water, ditch carbs, and eat more protein, and you'll be fit and whatnot. I don't know, right? I can't tell you this because I don't know your situation. I don't know your system. All I'm asking you is think about it. If this thing is really what you should be doing, because maybe there's something else. Maybe there should be like an alternative. Okay, because how it really looks like. Okay, our systems are no longer living in these huge mainframes. Our systems are more like this cellular thingies. You know, when you scoop like a small some water from a pond, right? And you put it under a microscope, you see these like amoebas or something like moving in the water, right? And this is how our systems look like, actually, because of microservices, because of distributed stuff, because of cloud and whatnot. So we are no longer like living 5,000 years ago, okay? And these systems interact with each other. Again, sorry for bad drawing. See, they can be, of course, many more hours, but like arrows, but this is how it looks like, okay? Oh, this transcription is very, very nice. I like it. It even put comma. Cool. Yes, and of course, our systems have internals, okay? These little organs, like, I don't know, like mitochondrium or like a core or kernel where the DNA is stored and so on, right? And as developers, we sort of like fancy testing these things and not testing these things. And now let me ask you this question. When you have a paying customer, because why do you work? Of course, like we like working for IT because it's like nice, it's fun, it's like assembling Lego bricks. It gives us like a tone of like satisfaction. And let's not be shy, it's also like a nice pay slip at the end of the month, right? We like it. And this is it, right? We also do it for living. And if we start doing systems that don't satisfy somebody's needs, that we don't turn somebody's needs into solutions, right, we're not going to get paid. And the thing that's answering, let's say, ordinary people's needs is the whole thing, okay? It's everything. So when this crucial, like poorly drawn line of communication fails, okay, people will stop using your system or will start complaining. That's the point, okay? So how it actually looks like. When you zoom in this microscope, it looks like this, more or less. This is this other system, and we think it's small, insignificant system. And our system is way more important, hence it's bigger. And this is the communication channel between these systems, right? I don't know, network call, REST call, like a message broker, whatever. And here, this circular thingy is a library. Think like JDBC driver or something, or JPA or something. And then when it comes to like interaction with our body, like the body of our system, we somehow treat it as a foreign body. So when you have something like a stick in your muscle, right, and it's not poisonous, over time, your muscles will like create sort of like a cyst around it, okay? And this is what we do in our systems. We sort of create these cysts, okay? Anyone like understands this I service or something service impl? This is the cyst. This might be the cyst, right? Normally, you wouldn't do that. Or like, let me ask you this question. If you have this I service something or something service impl, how many implementations do you actually have? Who has 2 implementations in their system? 3, 4 hands. Who has 3? Nobody. So why do we have this cyst around here? For mocking, isn't it? Yeah. So maybe because of that, we treat like the part of this like a foreign body. And of course, like ports and adapters and hexagonal architecture and thin architecture. So I'm not trying to tell you that every part of your system should be talking to this like foreign body library or something. No, don't get me wrong. It's just one of the reasons, if not the key reason, is we need to mock it, okay? So are there alternatives? Right? In our tests, sometimes, like when we have this old-fashioned integration test, we talk to a real database, okay? We talk to a real database, and this is the real database, okay? Like we have like dedicated instance that's used for staging or whatnot. Sometimes we're not talking, for example, to cloud provider, but we talk like we deploy something, let's say, local stack, right, from Amazon. And we deploy it again, and this might be this thing, right, which is like not real local stack. I mean, contrary to the name like local stack is not local. Like you can't have it local. It only lives in the cloud. I mean, funny naming. But remember, naming is one of the hardest two things in IT, of course. Or where you can go, for example, you can go for wiremark here, right? So you can have like this open API specification. You can have like pre-recorded, or you can even like snapshot like bunch of like network exchanges and whatnot, and you can have wiremark, right? But still, like you're doing it like this, and of course you can have a mock here, so we can mock it here even before this communication, let's say, net over network happens. So this is how we can test stuff, right, before we go for production. And maybe there are more things to cover. What if we want to go for some chaos engineering? What if we want to see how the thing will behave if we cut the communication here and go for alternative network channel? What will happen then? Do you test that? Of course you do, in production. Now, that's the point. And the whole idea is to maybe test it before. Okay? So, I hope I managed to maybe not convince you, but at least make you think that integration tests are needed, because if we don't have integration tests, this is what happens. Okay? So, now let's see if they're really simple. And I would say they quite are. Because of, for example, test containers. So you don't have to use, or whenever you want to do integration testing, you don't have to go for test containers. Okay, there are also other options, but I like test containers for a number of reasons. One of the reasons is that there are libraries for quite a few languages. Okay, they're already there, they're available, and there are new ones emerging, like Oleg is doing like C, C++. Port as well, okay, or a clone. So whenever you have like a new technology, and we have these microservices, and we have them because, of course, we're polyglots and whatnot, you can go for a different library. And how does it work? There is no magic there. Test containers stands on the shoulder of this giant. And what's the name of the giant? Docker, exactly. The name of the giant is Docker, right? So this is our giant. It's just as it is with the giants. Sometimes, especially if you're new to the industry, if you just graduated, these giants might look scary. Okay, so the job of test containers is to make this giant like actually a nice furry pet to work with. Okay, this is it. So under the hood, test containers requires Docker, and I've been invited like a month ago to a very nice podcast by one of the Polish podcasters. The podcast is called Better Software Design. And I was told maybe you can even listen to this episode if you use like Spotify AI, whatever that is, that it can translate from Polish, because we were chatting in Polish. And Mariusz asked me, because he asks every person who he invites, like, how did your journey with computers start? Right, and my journey with computers started in like elementary school, like unfortunately decades ago. And we had two of these brilliant machines called Commodore 64. And on like big occasions, we were given these machines because we weren't able to use them daily, because we could break them as a bunch of children or teenagers, right? And at that time, these machines didn't even have like a floppy drive. Okay, they had this thingy called data set, if I'm not mistaken. Okay, so the programs or the games, because we are more into games, were like written on a tape, on a magnetic tape, like a cassette. And fun fact, you could record them from the radio. They were like at night, they were broadcasting them. Yeah, some people are nodding. Yeah, we're in a similar age, right? And the most annoying thing in this whole data set was this tiny little hole. Okay, because I don't know like what the details and stuff like this, but there was a little hole, and inside was like a little screw, and you had to adjust the reader, okay? Because every type is slightly different, so you had to like adjust the levels and so on and so on. So when you've taken a cassette from one data set and inserted it into another piece of software, a piece of hardware like this, right? You had to adjust for the original one or something like this. And Mariusz, this extremely clever son of his mother, you know what the guy was doing? He was going to his friends with his own data set. Not just his tapes, but his own data set. So when he went there, he just hooked this device into their computer, and there's digital signal there already, I guess, or I don't know, or at least you don't have to adjust a cassette with this device because they already like adjusted, right? So this smart guy actually invented Docker like 30-something years ago, if you think about it. Okay, it worked on his machine, so he was literally taking part of his machine and plugging it into friends' machines. Okay, and this, if you think about it for a second or two, this is the idea behind containers and test containers in general. Works on my machine, so I'm shipping my machine, right? And the promise behind test containers is as long as you have this computer to plug it in, being Docker, right? You can take your data set, you can plug it in, and it will work. It will work on your machine, it will work on your machine, or your machine. It will work on CI delivery pipeline, on Jenkins, GitHub, Bitbucket, whatnot, okay? That's the whole idea. In your tests, you create this tape, put it into data set, and everyone can use this freaking piece of hardware, okay? So, for today's presentation, we had some needs. Right? Our granny called us and said, "Look, my child, I need you to have this. I need you to organize, right? Install this smoke detector for me." So what are we going to do now? Is we're going to build the smoke detector again. Okay, only this time in programming language. And since this thing used to be called Javapolis years ago, fun fact, we're going to use Java, right? So. I warn you, this is for demo only, okay? This is not how we build software like for these embedded devices, okay? It's for demo only, for demo purposes. So we're going to build and test, mind you, test CO detector, which starts in less than 4 seconds. Assuming I plug it in, it takes 1, 2, 3, 4, and it's operational, okay? Then it has to check for the registered particles every second. So every second, let's say it will do bling, 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 right? And when we have this totally, out of thin level of CO particles, then it raises an alarm. Basically, it will print alarm to standard output. So these are our needs. And I happen to have this detector already pre-built for us, right? So let's go quickly through this code. And how does it look like? So I have this alarm level C. It's this. I'm going to count CO particles and other particles, and I'm going to detect them using HTTP server. So let's say every request to this server is 1 particle, okay? For the sake of this experiment. So this is the main method, okay? And who's into Go? Who can program in Golang? Okay. No. Okay. So I will explain. In Golang, there's in this standardized many things in Golang, and this is what I like. They even standardize the formatting of the source files, okay? But they also have sort of this standard of putting logs, okay? It's called FNT, basically. So here I'm sort of recreating this because I like it. So it means whenever you put a log message, you have like a key equals value, key equals value. So it's easy to parse, right? You know how to parse it. It's like a map of things, all right? So I'm putting when I'm starting this thing, right? And then eventually when I start it, I will put started, okay? And then I pass the integer from environment that's given from the environment variable because this HTTP server has to listen on a port, right? I build this detector and I start operating, okay? And how this detector look like, I'm creating HTTP server, right, on this port. I'm creating a context. This is how we can build actually a very simple web server in Java, okay? You don't need a third-party library. Java's alone, JDK is enough. If it performs well or not, it's another thing, but for sake experiment, it works. So this is our response, like a placeholder, and we get the request method. And if the request method is paused, then we're going to capture the particle, and the particle is simply like it's the body, okay? It's the body, and the body is this. If the body is CO, right? In any case, we say it's a carbon monoxide. Else, it's another particle: oxygen, nitrogen, hydrogen, whatever. Okay. And if it's get, it wasn't specified, but just for a sake of experiment, I'm going just to give us a report, like saying how many particles of each kind have we detected, right? And yes, so this is how we create the server, right? And of course, this is how we create the response. It's like, regular stuff. And of course, we're going to execute this server on virtual threads because we're using Java 21. Especially in pet projects. And what does it mean start operating? We have this scheduled thread pool, okay? And at fixed rate, we're going to perform this check every second. So every second, we're going to perform this check, how many particles have we detected, right? And we're going to do something terrible, something that you should actually almost never do in production using thread sleep, okay? If you see this in production code, it means usually bad things, okay? But this is like for sake of demo, so I'm going to sleep for 3 seconds, and then I start operating, right? And how this perform check looks like, it starts with checking. This thing is called every second, right? And I capture the value of like how many particles, like CO particles do I have, and other particles, and then I'm going to divide Y by the another, and then I'm going to print alarm, okay, and that's pretty much it. So this is it. And then, actually, I'm not paid by JetBrains, but maybe I should be. What is the most important shortcut in IntelliJ? Optimize imports. Okay. Anything else? Double shift, someone said. The one I like very much is, at least in Linux, Control-Shift-T. It shows you this thing. The list of tests that already cover your thingy, or you can create a new thing, right? When luckily for us, we already have this detector test, okay? And how this test is going to operate. Just like with this thingy, or maybe this thingy, I'm going to build the whole box first, and then I'm going to test this whole thing as a whole, basically. So I'm going to use test containers. And how do you start using test containers? You go for testcontainers.org, right? And they have this very nice manual, like quick start and whatnot, and this is what you do. But what it actually boils down to is like you go to POM or build Gradle, and you start with this thing. So you put test containers in your test scope as a dependency. You put this thing in, and since then, you can, in your tests, use what I call a cornerstone of the code is online, folks. The slides are online, so we can chill out and watch it, right? The links are there. I mean, if you want to take pictures, I'm happy, but you don't have to, okay? It's already there for you. So I've built the whole thing, and the whole thing is in Java usually is jar because, as Josh says, make jar not war, like, right? So we have this jar, and then I'm going to put this jar into this box to test it, okay? And how do I put it? How do I create the container? I do it like this. I say, give me OpenJDK 21, right, Slim, which might be deprecated, but it still works. And then I copy there my jar, which is created, like my Maven package, right? I put it into TMP detector here. I say, you will be exposing this port to the outside, okay? And then I tell it inside, look, this detector port of yours is this thing, right? This is how I set environment variable, and this is the command I want it to run. So I say java-jar TMP detector, right? So this is how I create the container. And I have a bunch of tests covering what the needs we had. And as you can see, someone smart was already here because they disabled all the tests, right? Because this is what you do when the test is flaky, right? Or not. Just fix the damn thing. Right. And how are we going to use it, or how are we going to test if our thing really starts within 4 seconds, okay? So I'm going to create this container and use it in try with resources. And why try with resources? Because then it means here my container will be cleaned for me, okay? So I manually start and clean containers, okay? And I start it in here, and then I capture the events, so I can go for the container, ask for the log, chop into lines, and I can filter those that start with start, and I can see, this is the beauty of log-fmt, I can parse by the equals and see like the event and when did it occur, okay? And I assert that they are both starting and started. I also check that there is checking, right, that the thing is operational, and then I compute the difference between starting and started, and it should be no more than 4 seconds, okay? This is what I do. Okay, so let me, what was the shortcut? Let me try to run this thing, and that should be, sorry, yeah, this thing. I'm building a package, and then I'm testing the package, okay? Let's see if that thing works. Oh, apparently it doesn't. Oh gosh, build failure, ooh, Allah, Allah, Allah. So what does it say? What does it say? Expecting this thing to contain key started. Okay, so this assertion has failed. We have starting, but we don't have started. Okay, so does it log the thing or not? But let's go back to this actual code, and it says, no, I'm printing like starting and started, so what the heck? And the thing is, maybe we are misusing test containers. And what do I mean by that? This is a concept that's basically not so well known in Docker itself. It's this. When you start a container, okay, for testing, you need to know when the container is ready to sort of like accept the incoming traffic, for example, okay? Therefore, in test containers, we have this concept of waiting strategies. It basically tells you when this container is ready to be used in tests. In other words, when this call should stop, okay? So I can proceed and start like looking for logs or something. And by default, if you expose a port, it just looks for the port to be exposed. If the port is open, it assumes, the library assumes, that the thing is already ready and the container is ready, right? But fun fact, no. So let's go to this detector. Oh, come on. Sorry. It's like I have a fancy coloring. Yeah, see, I'm starting operating, so the HTTP server inside opens the port in here before I print started. Okay, so the library assumes it's already operational, but according to us, it's not operational. So what we have to do, we have to tell the library, you have to wait for this specific log line. Okay, there's like a number of waiting strategies, but one of them that we can use is we can say just waiting for and wait dot for log message, and it's going to be started equals anything, and we expect it once. Okay, let's run our test again then, and keep our fingers crossed. Maybe it works. We shall see. We shall see. Yeah, build success. So now we have tested that the actual thing starts within 4 seconds. Okay. So I guess we can go for another requirement, which is checking registered particles every second. Okay. So we have to do what? Enable another test. Right? Yeah, and let's see if this thing works. Right, so run test. Okay, because you see it works like from IDE as well. All right, so you don't have to like do it on a CI only fashion or whatever. It should also work with yeah. So this thing is disabled. This is the test that we just enabled and fixed, and this is the test that's failing, and it's failing. And why does it fail? It tells us, yeah, because what this test actually is doing. Well, let's go back to the test first. I again prepare the container, I start the container, and then I'm going to check the events, the checking events, basically. So every time our LED blinks, saying checking, because this is what it does, right? In this executor of ours, right? I first capture the check events that I have before ascensions, because as we've seen before, it already starts blinking even before it started, right? So I need to capture how many checking events I had before my test. Then I wait for like between 3 and 4 seconds, and I expect at least 3 more checking events, at least 3 more blinks. So basically, you take a stopwatch, right? You wait for like 4 seconds, and you expect 3 times the blink, at least 3 times, maybe 4 times. Okay, so I'm using a Waitility for this, a great tool. And yes, so I say I asserting this like again until I have this. I filter these events, these checking events, and I subtract this initial number from current number. Initial number and current number, and I get at least 3 events. So it failed because it didn't have these extra 4 events, right? And just, sorry, I'm stressed, I've forgotten to show you. These are actually the logs, right? When you start an integration test, these are the logs. So it's just discovers, maybe you have like overridden settings from in Testcontainers properties in your home directory, because this is how you can manually tune Testcontainers. Then it found that a Docker environment, because I'm running Linux, so it has this very local environment, right? And then it like shows you the Docker host. It checks for the Docker, if the Docker is really there, at least 1.6, which is an ancient version by today's standards, right? And then it's creating a container image, right, for this thingy here, and then it's starting Ryuk. What is Ryuk? Ryuk is, well, some say it's an angel, and then we get to dispute. Some say it's like your savior angel that saves you, and some say it's angel of death. Actually, maybe it's both, because what it does is like if you forget to use try with resources, okay, rely on the library, you just call start and you never call like terminate, okay, then it will eventually terminate everything for you, unless you disable Ryuk, okay, but that's another story. And then it shows you how long does it take to start a container. So this thing, you know, it was starting, and it started in like, you see, 4.28 seconds and whatnot, and then we have the test, right? So it returned false because it didn't bling, bling, bling within 3 to 4 seconds. And, you know, in IT, we have these 2 major problems, okay? We have problem with naming, we have problem with cache invalidation, and we have problem with off-by-1 errors, okay? Apparently, there's also one more problem, which is math, right? What you shouldn't be doing when it comes to math? Come on, what's sort of illegal in mathematics? Who said divide by 0? Okay, you get jealous. I throw, you catch. Okay, we try. Yeah, great success. Very nice. Exactly, we don't divide by 0. Okay, yes, so when we perform this check, and we will divide number of carbon monoxide particles by all other particles, when we just start initially, how many all other particles we have? 0, exactly. That's why this whole thing blows up, and because it's in a separate thread, we don't see these stack traces and whatnot. So we have to say here, just do this checking only if, sorry, that was big decimal 0 equals all, sorry, is not, right? Don't divide by 0. We have a very nice thing in Polish about this, but I won't annoy you with Polish too much. Yeah, so let's try to rerun the test, okay? Let's see if it works this time. Come on. If we have a volunteer, someone could look on the internet for dad jokes, okay? And when we're waiting for the build, someone could entertain us, or maybe not, because we already have build success, okay? So we fixed the thing, right? Now we check that every second it blinks. And let me go to the very most, like the most needed, the crucial requirement, which is this, that it actually detects the gas. You know, the canister, when I spray it, it actually detects the gas, that which we should be doing, okay? So again, there must have been like a junior developer. Okay, never mind. So what I'm going to do in this test is I'm going to intoxicate the atmosphere inside this container. Okay, I'm going to spray some gas, and it should be poisonous enough for the detector to raise an alarm. All right. So what I do again, I create the container, start the container, and I create an HTTP client, and it's auto closable since Java 21. That's why I have this hint. Hey, you're not closing it. Yes. So I then want to create an URL, right? So I'm going to send requests to the thing inside the container. And how do you create a URL? Let's start with the easy part, with the port. You just go for the container and I say get first mapped port. And it works because I have only one port exposed. So the only one is always the first one. Okay? If I had several ones, because sometimes you have several ports, then you have to go give me the mapped port for this exposed port. Because as you may know from Docker, when I expose a port right outside, it's mapped internally to a random port inside. Okay? That's the thing. Sorry, it's the opposite. When I expose it inside, it's mapped to a random port outside, of course. Yes, so I don't know this port and I can't hard code it. Therefore, I'm going to say, where am I here? Like, give me like this port, whatever random number it is, this time, right? And then I say and go container get host. And you've seen in the logs, I'm running it locally. So why I just don't go localhost? Because sometimes you might have Docker running elsewhere, okay? So what Testcontainers needs, it needs to be able to call Docker, right? Just like my friend with dataset needed to connect it to a Commodore of his friends, right? Testcontainers needs to connect to Docker. But fun fact, this Docker doesn't have to be local, okay? So when it's not localhost, okay, then your thing would fail. So then you could have beautifully running tests locally, but failing in CI pipeline, all right? That's why I would say, almost never go for localhost, you go for container.getHost, all right? So we have the URI, and then I'm creating a request with oxygen and carbon monoxide, and then I'm going to send 1,000 oxygen particles and just one carbon monoxide particle, right? And I expect this thing, like, yeah, this whole container, like, or this request should be sent within like 10 seconds, the worst. And then I'm waiting at most 1 second, right, for the logs to contain alarm. Okay? This is like, because I'm a friend with this great Spanish guy called Manuel. Are you friends with Manuel? I'm friends with Manuel, that's why I know it should be 1 second most, okay? Always be friends with Manuel. Really, like, people, like, reading for 1 hour can save you 5 days of testing. Okay, so let me run this test, okay? Let's do it like a CI fashion again. It will take, of course, longer because I'm starting the container now 3 times. So this is like a time for mandatory fun when I have to annoy you with my dad jokes. So I asked this question in the Netherlands, you know, the people from Netherlands, right? And they asked me this joke, like, do you know why 2 guys from Netherlands didn't starve on the desert? They had sandwiches. Really terrible joke. I mean, those blokes in the Netherlands. Okay, never mind. The test fails. Do we know why the test fails? Any ideas? We're not dividing by 0 anymore. So why could it fail? Exactly, I don't know as well. So this is the beauty of shifting left. We should be able to run this thing locally, okay? So let me go and run the tests locally. I've set the breakpoint here, right? And let me run the test. Maybe we should just run this thing, okay? Save ourselves some time. Maybe it should work. Let's see it works. Like, you know, these tests, they always flake. You never know. Okay, the test is running. Did I click debug? Yes. Okay. And now, this is like this lovely situation in these gangster movies when they get into the bank and shout, "Everybody freeze!" Okay? We froze the things. Okay? Let me just go and see Docker PS. See, and we have these containers there. So this is our container, right? The one that we have with the detector, and this is the ryuk, okay, the angel, if you will. And now what we can do is like, okay, what do you think is the actual reason why the test isn't passing? Any ideas? I have these lovely stickers, but you have to shout. I don't hear you. No alarm. Yeah, there is no alarm. Okay, the alarm is not printed. That's the thing. But why isn't it printed?
You switched around to minus the mathematics.
Yes, but let's see if that's really the case. So one of the things I can do, I can go for like this. I can go for curl and then say HTTP and localhost. Sorry. See, I'm host, and then let's say this mapped port is this port, right? See, I'm not good at, especially when you're doing this live. Right, this thing. See, I've sent a GET request, which means I can freeze everything. I can examine my containers, and we've detected these particles. So there must be something wrong with like how do we measure the thing. See, I could also do this request from Java and see like in Java again, right? So let me stop this test and let's try to follow our friend's advice if that's really the case, right? And yes, apparently, excuse my French, we still suck at dividing, because when we divide an integerish big decimal by integerish big decimal, it wants to give you integerish result. So it's going to be 0, okay? So we have to tell this divider be that specific as this alarm level. So we say alarm level dot scale, right? So be that picky, that specific, because this thing, C, has these fractions, right? Okay, so now let's try to run these tests again. All right, and let's see if they work. Any dad jokes? Anyone? So what did the ocean say when it met the beach? Nothing. It just waved. Yeah. Build success. Very nice. We have it working. I have a sticker, this beefy edition for you. There you go. Yeah. Exactly. That was the thing, right? So, very nice. We have done it, right? We've done it. We have created this smoke detector of ours. We satisfied all the requirements, right? The requirements are here, and we can deploy it to production and be happy and live happily ever after and whatnot, right? But then it's like a Friday afternoon, you come back from lunch and your PM slash PO slash CFO slash anyone says, look, we can't afford it. We can't run it as a jar in Java. Have you seen this container? It's too heavy. It won't fit into this hardware. So what can we do then, right? We've built something, but actually it's useless because it can't be deployed there, right? So, of course, you start brainstorming, somebody shouts, let's rewrite it to Rust, right? And, of course, what you do, you throw this person out of the window, and then you keep running as headless chickens, right? Because, what do we do? What do we do? We're doomed, right? Because it's like, it's Friday evening, it should be live. And even if we rewrite it to anything, then no way we're going to test it until then, and we're basically screwed. Or you may say, hold on. I've been to this talk at DevOps, and I can show you how we can do that. We can still use this test suite. So what we need to do is, since you're not with Alina listening about Graal native image. What's this? There's like a music, and I don't think I turned it on. Oh, it's my... Oh, sorry. It's like, come on. I don't know, mute it, please. I've turned it on in my pocket. Sorry, I didn't plan this. Yeah. So what we're gonna do now? because someone came and basically threw the table into the air, and we need something that's native image, right? So what we're going to do here is we're going to go to, and I'm going to make things a little bit faster for us. And what's the shortcut? I forgot. So it's, let me disable this. How was it called? Presentation mode for a moment. And this thing is this Git, it's Alt-9. Okay. So we'll be using Alt-9. See, this is live, so we go for this thing, and what I'm going to say, see, we had this third test in action, right? So let me only like roll back all the changes here, so we don't have a conflict. Here, and let's roll back here as well, and then let's go for this growl in action. And let's go and check out this revision. And what we have now, I didn't touch the detector itself. I just extended the test. What we have now is this. We need to build this native artifact, okay, somehow, and then put it into container and test it, okay? So the container, let's say I have this detector native build, this artifact, right? How we build it, we'll figure out in a moment. And I copy it as sort of, I borrowed it from Windows. It's going to be like executable, therefore it has to have this X executable permissions, right? And I'm going to have the Alpine image. I'm going to copy this artifact, this native image, into here, and then again, you see everything is the same. I just wait for started, expose the same port. It's only I call this command because this is my native image now, right? And how do I create this image, or how can I create this image with test containers, right? So I can like delete this thing if it exists, like artifact detector native, right? And then I use growl container. And then I copy my jar into this container, okay? And then I run it with command that this is like native image, and then I go native image, static jar, TMP detector, and this is when I want it to be created, okay? And then I have to basically get, or I mounted it. You see, I mounted this where I keep this native artifact, right? I mounted it to TMP artifact. That's why I'm creating it here. And I wait for finish generating, okay? And then I have this image generated, and I start the container. And this is my before all, okay? So before I even start testing, I create from my jar native artifact, okay? So let's see if this thing works. Come on, I don't see the command. Yeah, let's run it. Oh, not here. Sorry, I've missed the enter. The thing should be here. Okay. It may take a time, you know, because it's this native image, right? Which brings us to more dad jokes. Do you know why medieval times are called sometimes dark ages? They had a lot of knights. Yeah, it's really bad, I know. Now it's your turn. I'm looking for a volunteer that could help us and entertain us with dad jokes, because these integration tests, as you know, they're really darn slow, right? They're doing something. That's why you usually go for this, you know, like office chair kayaking. Do you know this office chair kayaking? I'll tell you with the next thing, because the build is done. The build is done, and it's build success. Very nice. So see, it created for me, where are you? It created for me inside this artifact, it created this native executable, right? So I have this native executable, and this is something I can pack into my containers, okay? So what can I do with this packing? Right, like I can go and I'm using this, okay, let's go for, growl in action. Let's go with, there's another approach that you can go without mounting, actually, because mounting may not work for like remote builders. Let's go, if I can do one more thing, which is actually publishing the image, right? So I will start the build and I will annoy you in meantime, describing what it does, and let's keep our fingers crossed that it really actually does. So what am I doing here? I still have my tests, my 3 tests, I didn't touch them, right? And I start now my container in a slightly different matter, right? First, I have this after all extension. We'll get to that. And you see I have this jar file. And this, again, when I keep my detector native image, right, after it's built. And this is where I want to publish my image. I want to publish my image after this whole build into Docker Hub, okay? So I create the native image again. See, this is how I create it, right? And because I need it to be like I want this container to not to start it every time. I say here with reuse. Reusing is a very nice concept in if you have sort of like a servant container, right, or a container that you can start and just keep using it, test after test after test, or after you run it for the next run, you can go for reuse. It requires this thing, and it also requires one thing, which is in your test containers properties, you have to enable this flag, okay? These two together, because it's like experimental opt-in feature, will make your container not disappear after the test is run. And the test is run, and let me go and say docker ps, and it's still running. As you can see, this Graal image, it's still running. It won't stop, okay? Yes, so now as you can see, wait for, every time I create it, I tell it to execute this thing in a container, right? Which means, hey, build me native image from this jar into this thingy. This is absolute minimum. It's not recommended way for building native images, but you can like get away from it, especially on Fridays, right? And then what I do, I copy from this container this file into my native path, right? And that's it. And then I also prepare the image. So as you can see, I'm creating now this container now here, right? And after I have this container created, just as we did before, like so to the Alpine, I'm copying my native executable. I waited for it to start and so on, and I tag it locally. Okay. So then what it means, I basically say that this is going to be my smoke detector latest. Okay, and then after all tests are done, that's why I use this after all extension of Jupyter, JUnit 5. I basically have this as test watcher. So when every test passed, I can check if it passed or not. And I have this after all callback, right? So I can say if a test failed, I can say some tests failed, right? And if none of them failed, this is going to be false. And if it's false, then I can say push the image to the repository, and it would say image pushed, just like it said or didn't, it said it here, right? It said image pushed. And you can do this like this. So you can tag the image like this. You go for the container, and then you have to go for a commit command. And this is like, unfortunately, this is how we leak the internals of the things that test containers rely on. Okay, so now we're exposing to Docker Java API, which should be visible in the imports here. See, right? So, like, it's like this is where dragons start to appear. But I promised you that I will show you that test containers is not only needed and simple, but also powerful. So as you can see, instead of doing that in YAML, that you tag the image. Okay, I can tag the image here in Java code, and then I can push the image to repository also from Java code, right? So I can say push the image, right? And if there is an error, I want to have like a runtime exception, and I wait like at most 180 seconds. And let's even see let's go for Docker Hub, and this is my private Docker. See, it was pushed 3 minutes ago. So I didn't lie, okay? So can you please tell me, now let's go for this. And yeah, so this is how you can tag image and push image and, sorry, wrong file, this thing. Yeah, this is the file. It has these 3 tests. We're building a container. We're building a native image. We're pushing the image and whatnot. So what is in this file? Any ideas? What it actually is? And just to remind you, I called it like this, right? I just went for this one-liner. So if you will, this whole file is your whole CI/CD pipeline. This is what it basically is, if you take a look at it from like 10,000 feet perspective, okay? It builds the artifacts, it tests the artifacts, and then it pushes the artifacts, okay? And the best thing about it is no YAML. Okay, now the question is, I have more stickers to give away. Can you tell me what YAML stands for? Nah, yelling at my laptop. This is what it actually means. When you're yelling at your laptop. See, this is Java code. I could write it in Go, and I'm testing native stuff, right? So I have tests written in Java, testing artifact, which is no longer in Java. So it could be written, like now we go to this guy, we recover it, and say, we're sorry, we shouldn't have thrown you out of the window. Now we have time to rewrite it to Rust, okay? And to Go or whatever you please, if you will. Maybe I shouldn't be saying this at a Java conference, okay? But hey, I have my tests written in Java, and it's not the tests alone, it's the whole freaking build pipeline, okay? And no YAML and whatnot. And I can stop it, I can debug it, it runs on my machine, it runs on CI, and so on and so forth, right? So I hope I managed to cover the last part, which is powerful when it comes to test containers. You can really do a lot of stuff with it, right? Because when you take a look at test containers from a certain angle, it's not just test containers. It's actually about containers, right? You can think about it as a wrapper around Docker, if you will, right? Or sort of like infrastructure as a code, because I have just code, and it's not even in YAML, right? And I'm managing my whole infrastructure. I'm just building, testing, and then publishing the artifacts. This is what I do. Let's go back to this slide. Okay, and now maybe I should be running like back and forth, and I know camera people. What's this axis? What's this axis? Well, if you were to describe this axis below this drawing, this poor drawing of mine here, what would you call it? X. Okay, but apart from X, time. I hope we're getting closer. Time of what? Times of what?
Where you are in the development process?
Where I'm in developer process. Yeah, I love how you think. Yeah, let me turn back to you for a moment. How do I see this thing? So, obviously, running tests with like mocks is fast, okay? And running this test, as we have seen, takes time, okay? So when it comes to time or cost of execution, obviously it grows here, right, to the right. But then let me ask you this question. What's the cost of maintenance? Okay, when this library changes here, right, but the thing you're testing, this real thing changes, you just do nothing, you just bump the image, right, and that's it. Whereas here, you have to go for the changelog and maintain your mocks. Your mocks, stubs, fakes, test doubles, spies, models, whatever you call them, right? I don't know if they made this joke, but when they nominated me as a test containers community champion, they said, I'm using test containers to ease the tedious nature of maintaining all those mock stubs, spies, and fakes, and so on and so on. Because I'm sort of am. Because let's say the smoke detector changes, right, or something, or another dependency of your changes, or this, like you have this mock for this service that other team made, and so on. So they released a new version. So what do you have to do with mock, stub, fake, double, whatever? You have to update it, right? You have to maintain it. And you have to make sure that two things did happen. That in your mock, you reflected all of the changes from the changelog and all of the changes that are not in the changelog. And let me tell you a story. There was this story, and people ask me, why didn't you use test containers back then? It's because the bug I'm going to tell you about happened even before Docker, right? And test containers itself is just 1 year younger than Docker. So the story was this. There was a system in production, working nicely, even generating some income, right? And it was using PostgreSQL 8. It was 8.3 or 8.4, I can't remember, right? It was like a Java application in the time when we are making ERs and WARs and whatnot. And someone came to this brilliant idea that we should upgrade PostgreSQL in production. So basically in CI, they installed a new version of PostgreSQL, they gave it a spin, and things appeared to be running smoothly. Okay, yeah, there was like, I don't know, 5 integration tests or something, because the integration tests were costly back then, okay? So yeah, things went into production. And then people started calling after a week or two, because what has changed? One thing has changed, that there's this type of data in PostgreSQL called byte A, if I'm pronouncing it correctly, and it changed like PostgreSQL 9 introduced a new way of representing it, like not internally, but giving the results, okay? And fun fact, nobody upgraded JDBC driver, okay? Because there was no need for that in tests, because all the tests were mocks. They had this mock DAO at the time. Okay, so the thing was using GPA or Hibernate. So how does ORM works? It reads a chunks of an object tree, right? Do something and writes the tree back to the database, right? So it read part of it, changed something, and wrote it back. It's just when it initially read it, it read the data in a corrupted representation. So over the time, the data was corrupting, right? So what we had to do? Of course, go for the backups, go for a partial restore, because the system moved like 2 or 3 like weeks forward, and so on, right? So these things are fast because we're into this mode. My test need to run in like 3 seconds, okay? But when you have to maintain them, the cost of maintenance actually, I would say, grows on this side, okay? So when it comes to like getting confidence and whatnot from the system. And I promised my friend, head of open source team, one of the core test containers maintainers, Kevin Wittek himself. I don't know if any of you have been to our workshop last year. Kevin couldn't make it this year because of very happy personal reasons. And he says that he's not a great fan of using them interchangeably, right? That you should know when you're using a mock or a fake or something. And I promised him I'll mention that. But we had this lovely podcast, which I mentioned you, right? It says in Polish, about test containers, pyramid of tests, and quality of life. I'm here with Mariusz Gil, and we had this lovely conversation, and apparently it's so lovely that last week it was the most popular technology podcast according to Apple in Poland, okay? And it started like the whole avalanche of comments. And literally, I can swear I saw this comment yesterday when I was sitting in a train which was stuck before Antwerp and Central, because some folks were running in the tunnels on the tracks. So I had time to scroll Twitter, and someone wrote this on Twitter. I'll zoom it for you. Sorry, maybe like here. Oh, come on, here. Yes, I'm not sure, I wouldn't go that far, okay? I'm not sure that it's like correspondence scores of Taekwondo using mocks. I still use mocks myself. I still use like unit tests. I think they valid, they need it, right? And when you assemble the container of yours, I mean, it doesn't make sense to build all of this, okay, if where is it? If the blink doesn't work, okay? So the bling bling has to work. So you run like a unit test on this and every other thing, right? And you don't disable test. And only after that, you make sure that you assemble the whole box. Okay? Yeah. Because, you see, why I don't really care that much if the thing you're using is stub or mock or fake, and it's like, it's not just me, there are like people all around the world and starting this debate like months, maybe even years ago, right? Years ago, actually. Or why I really don't care if it's like a unit test or integration test, or if it's like end-to-end test or whatnot, because my business is not tests, okay? My business is this. When I'm on pager duty, okay, after Friday deployment or Friday release, I just want to sleep well. This is my business. I turn people's needs and people's problems into working systems, okay? And whatever gets me from here to there is okay, right? And just as I told you, you need to judge by yourself. You have to be in your shoes, in your seat, in your company, in your team. You should know which shape of testing pyramid is or testing like thingy is good for you. Whether it's still testing pyramid or reverse testing pyramid or this trophy or honeycomb or peer or whatever, I don't know. But just think about it and use all kinds of testing you can have, like, right? And as not just like mocking or this unit testing, not just integration testing, like combine whatever makes sense for you, because it's about the cost, right? I've heard about these silly quality gates when you have to generate this, sufficient code coverage for build to pass or PR to be accepted, okay? And then we end up with this testing getters and setters, right? We've all been there. And do they really give value, anyone? Does it really make sense if a developer spends time writing 10 tests on a mock and then maintaining the mock because another team made another change to their system and the mock has to be reflected? Maybe you should just invest initially slightly more time into this, using test containers, for example, and then just simply bump the version. I don't know. And just one thing for sure, when we went here, I said it initially, that, for example, you can also use wire mock for here, which is obviously better than the mock over here, I would say, because you're testing the integration over the network, for example, and that means you might get away from the syst, okay? But I'm not covering wire mock today, because it will be covered by wonderful Oleg's gang. There will be 2 Olegs presenting you wire mock Thursday, I guess. So please make sure, if you're more into this, like, okay, maybe I could like make this faster, use a mock on this side of the wire. How do I get this? Go to their talk. So everyone got excited. Yeah, we're gonna go back on Monday. We're gonna write this integration test and whatnot, right? And these integration tests are going to be so awesome and nice and integration tests all the way. Yes. Now we're going beyond the initial topic of the talk, right? Let's be real for a moment. These tests are slow, aren't they? Can we do something about it? And who do we usually blame for bad news? Testers. Yeah. Because they found this pesky bug, right? Or if someone brings you bad news, you blame the messenger, right? Oh, it must be test containers. Oh, gosh, test containers for sure, right? I would suggest that maybe it's a picnic situation. Picnic standing for problem in chair, not in computer. Okay? And I have this lovely project I would check with you. It's a sort of like a dummy project. Hold on. Let me just disable this presentation mode. And it's called TC Perf Up. Let's go for this window. Okay, we should have it. Right, and this is what I'm going to do. Right, I'm going to go here and paste. Let's run the tests. And fun fact, it takes like 8 minutes to run these tests. So why don't we take a break and meet here at 11:10, people? What do you say? Okay, it's Monday. Everyone can use some coffee, so let's have 10 minutes break. See you soon. Sorry, after the break, we'll be trying to optimize this 8-minute build or 7-something build to make it like reasonably faster. Thank you. 1, 2, can you hear me? Now you can hear me. Okay, so we're back from the break. Fantastic. One thing I could have forgotten to mention is there are stickers here, and these are like, you can come and grab some, right? These are like free for everyone, for you, for your friends, for your boss. And as you can see, this break was quite necessary because the build actually took longer than I anticipated. It took 10 minutes, right? And how does this whole project setup look like? Okay, so I have a bunch of unit tests. Okay, and the unit tests are really like simple like this. They print something, right? And I have this fake sleeper which should sleep for like 100 milliseconds just to like block it for a tiny little while, right? Yeah, so I have 6 tests like these, and I have 4 integration tests which work in this. I mean, I'm describing you this project, how it looks like, not how it should look like, okay? We'll try to improve this project till the end of this presentation. But the reality is that the integration test cases extend base integration tests, right? And each of these A, B, C, and D has 3 cases. So I'm going to check in if Johnny is here. Right, and I have 2 containers, which is a new container and old container, and then I print like the results, right? And yeah, the Johnny is here. And it's funny, see, it moves. When I click, it moves. Yeah, so here's Johnny, with Johnny, right? Isn't it a cool feature in IntelliJ? Like you can amuse people during your presentation with Johnny. Yeah. Anyway, sorry, let's not get distracted too much. Yes. So here's this base integration test, right? And what does it do? I decided to follow the docs or the usual approach, so I'm using the JUnit integration, which means in my POM file, I also have this, what is it? Apart from like JUnit, AssertJ, Humcrest, whatever you have, I also have this thing. So it's JUnit Jupyter integration of test containers. So therefore, my my cases can go with these annotations. So I can go, it's test containers, right? And then inside, when I have fields with containers, I can just say it's a container, right? And then this container is MySQL container of version 8.1, this 4.57. Let's say I'm working on a tool that's migrating data from one database to another database, right? For the sake of this experiment. I mean, I'm not doing this. Actually, there is 0 production code in this project. It is only test code. But this is what it does. And before each test, I'm preparing the containers. So I have here. You might have Flyway as well, but I have Liquibase changelogs, right? So I basically, to have my database up and running, I need to run a series of database migrations, right? And whatever tool you use, it's pretty much the same. We're not going that deep, right? So I prepare these containers, and so I run the migrations for this new database and old database, right? And I run these, and how you can run them. This is like in recent liquid-based versions. This is how we can do that. Basically, you have like this command and changelog and username and password, and I get them, as you can see, from DB containers. So I get the password, username, I get the JDBC URL, right? And this is the changelog file, and that's the stuff, right? And I ran this project, and as you might see, it took 10 minutes to run. And it seems to be quite simple, right? So I have like a bunch of unit tests, lightweight or fast tests, and I have like a few integration tests. But it's not the best or the worst news. The worst news is it didn't pass. So you had to drink this coffee only to figure out that this test suit didn't pass. I mean, how shameful, right? So we have this project, right? And I'm afraid this project is absolutely disgusting, right? Yeah. So maybe we can improve things in this project, in our lives in general, when it comes to integration testing, especially using test containers. So, yeah, when things are slow, it's always your three: CPU, storage, and network, right? So we try to take a look at CPU, at storage, and then network. There's a French, that's from Voltaire, I believe. The better is the enemy of the good, right? So we should improve things. So doing something once is obviously better than doing something many times. Okay, so this applies in general to IT or software engineering or systems or whatever. So we have to think if you can do something once instead of doing something over and over again. And if you have had enough memes during this presentation, which is absolutely understood, I can present it like this, more like scientific approach. So now we're talking like put your ties on and whatnot. Yeah. So we're going to run a test, like a number of steps or tasks, if you will, and see what we can do. Because if we scroll here and there, you see there was only one failure, and apparently nobody expects Spanish acquisition in test F. And this is it. This is it. This is the Spanish acquisition nobody expects. So, but this is a unit test, right? See, so a unit test failed, Blink failed, and despite this, we decided to build this whole machinery and put it under test, right? So I would say the first thing when you go into testing, right, especially integration testing, it's this task, right? Only run slow tests after fast tests have passed. Okay, make sure this is what we do. And there's a number of ways you can do that, okay? So you can, when you have your build tools, you can go for sub-modules or sub-projects. And you can say, for example, these long or slow tests are going to be in one of the projects, and unit tests are going to be everywhere else. Or you can go for profiles, right? So you have like a lightweight profile, and you have like a slow or I don't know, sluggish profile, if you will. And then you call test by the profile, okay? This is what you can do. Or what you can also do is, let's select this thing. Let's go for README again. The most trivial way, right, is to basically, like just to give you an idea what we can do, is sort of do it like this, right? Even if you can't touch your palm or something, you just go and first you call all the tests that are not unit tests, okay? Sorry, that are not integration tests, you see. They're not integration tests, and only then, if this is successful, we go for integration tests only, because there is no reason to repeat the previous ones. And of course, you shouldn't clean. Sorry, that's a mistake, obviously. We shouldn't clean here, right? You shouldn't clean in general, like never. Yeah, so this is the, I mean, in Maven, okay? You clean your apartments and kitchens and okay? That's because then you get it out of the context, and Piotr said, I shouldn't clean, darling. No, you should. You should. That improves quality of life of everyone, especially people around you in the bus. Trust me. Yeah, so this is the very first mistake, okay? If there's Spanish Inquisition in fast tests, that are not using dependencies, there's no reason to wait for 9 more minutes to discover these if the whole test suite can run in, I don't know, 2 or 3 seconds, something like this, okay? So please separate your tests. I mean, you don't have to separate them in a test base. You see, I'm still gonna run them the idea is that during this experiment, I'm not going to touch this test, except fixing this test F, of course, right? So I'm not going to rearrange them. I'm not going to introduce like a profiles or I'm not going into like show file and fail safe. That's also an approach and whatnot, right? It's just you have to logically somehow separate the execution of fast test and slow tests. Okay, that's takeaway number one for us, if you will. The next task is start the containers only once. Let me check this thing out, right? And we'll run it in background because it will take some time, and I will try to explain in the meantime what we're doing. So I'm copying this because this is the only thing I'm gonna need to run. Let's say I keep running for now unit tests. They should be passing, right? So I will be running integration tests only. So they should be running in the background. In the meantime, I will explain what has happened here. So we went into this base integration test, right? And previously, these fields weren't static. They were just ordinary fields, instance fields, right? Which means whenever Testcontainers library sees container on a field, it restarts it when it logically makes sense. If you have a static field, it will start it only once, when the class is initiated, sort of, right? Whereas when it's an instance field, every time you run a test, the whole container will be started from scratch. And you might be wondering, so why doesn't it like throw an exception or something? Well, sometimes, like in the smoke detector, we needed to start the container for every test, right? Because when I'm testing the startup behavior, I mean, I can't do that in any other way. So it's not like logically flawed to start your container for every test if you really need to. But most of the time, you don't need to do that. What you have to do is to start your container once, like your database container. But then what we have to do, what we also have to do is we have to drop the database, right? We have to, because like, okay, these tests were only checking if John is here. But normally when you have tests, okay, you have tests that write something to the database, for example, okay? So the idea is instead of stopping the container, like garbage collecting it, I am starting a new one, I'm reusing the same container. And there are, again, many approaches you can do that. Some people, for example, create new schema. That's also like an approach. Or the approach I've chosen here is like I drop the database and I create the database, right? So I drop it and create it for a new database and older database. And then again, I run the migrations. And then I check if John is here, right? And so this is what I do. Instead of restarting the container for every test, I start it just for once, right? In this static, or I ask the library to do it for me. And let's see if the test has passed. The tests are still running. See, they're taking time. Yeah, but this is basically the idea what we should be doing, right? And if we take, if we take a look, it shows you when you see it's like this liquid-based thingy, but it should show us also somewhere in the log. Where's the log? Come on, where is it? It shows us here that the container is starting, right? And then it waits for this thing to be successful for select one. This is its waiting strategy, right? Because when a database container opens a port, it's not enough. The database under the hood or inside the container has to be working or responding to our requests, right? And then you see that this thing started in 34 seconds, right? And then the other thing is starting again, and this other container, this 5.7 starts in 14 seconds, right? So are we done there? Are we done yet? Come on, scroll, please be finished. Okay, now I have to go for dad jokes then. That's really unfortunate. Yeah, because we have to wait for... Okay, it's done. 3.5 minutes. Almost 10 minutes, 3.5 minutes. Improvement, like 2 or something, maybe even 3 times closer, right? So we're moving in the right direction, right? So make your things static, right? It's in the README, it says, always be friends with manual. You can make that by making all container field static, okay? So then we go for a next task, and the next task is, do we really have to start the containers one by one? Okay, let me check out this revision, okay, and let me run it. And sorry, zoom in, come on, you clumsy boy. Normally I use this, I have like this very nice fancy ergonomic keyboard, but I don't have it here. So let me go and copy this thing. I mean, this laptop is always like such a pain. That's why I'm not a digital nomad. I can't just travel with the laptop. Yeah, and the tests are running, so I will show it to you. And that's why I didn't run it here, because as you have seen, we started one container for 34 seconds and then another one for like 15 seconds. Okay, how many cores does your computer have? A few. Not one, a few, right? So why do we have to run this thing sequentially? Why do we have to start one container, wait for it, and then another thing? And I'm also like, maybe not cheating, but I have these images pulled, right? Because, conference Wi-Fi and whatnot. So if you're running this from scratch in your CI environment, what you normally see is this. The first container is pulling its image, or like, should I say, the test containers is pulling image for the first container, starting the container is starting. Then it's pulling the image for another container, then it's starting it, and so this story goes. This slow train is moving really, really slow, right? And you've seen that in the log. So what we can do instead is like we can say, hey, why don't you all folks start at once, right? And I go to this base integration test, and I basically say parallel true. This is new thing since 1.18, test containers 1.18, so it's not that new. It's like 1 year old, more or less, right? So then you tell the library, look, I have enough computational power, so you run this thing and this thing at the same time. Okay, when I hit this, but basically what I want them to be started in here and in here. Okay? So let's see if I annoyed you enough to have this build finished. Not yet. But we already see that this is happening. See, creating container for this image and creating container for this image and waiting for a database connection for 5.7 and waiting for database connection for 8.1. So both containers are started at the same time. So I'm not waiting 34.15, but I'm waiting 34 because it's the longest one, right? So the idea is not to only start your containers once, but also if your CPU and computational power basically permits to start them all at once, right, or at the same time. And of course, it will be probably a slightly bit more than 34 seconds because then I have to, when I have like really a lot of containers, then this 34 seconds becomes longer, right? Because I'm busy doing also the other thing. It's still starting. See, that's why it's not 14, it's 18, more or less. Okay, shall I really have to look at these dad jokes? Okay, not. Okay, instead of 3.5, we have 250. Improvement, because we shaved this 15 seconds. But then you go, hold on. It's more than 15 seconds, right? I mean, the difference is more than 50 seconds. So what's the thing? Let me see this task. Maybe you're still starting the containers too often. Let's take a look. So I was starting. I'm running this liquid-based thingy, and I'm running it, and let's see, I'm starting the container, right? And this is a fresh tab, so I go up, and then I realize, that's why you should also read logs, I started it again. How come? Despite being static. Oh, interesting, right? Well, do you remember what they told you last time, that it's composition over inheritance? So when we inherit from this test 4 times, For every time it thinks it's a field of this class because it's, like protected and whatnot. That's why it's starting containers for every test class, and we have 4. That's why allow me to check out the next revision. Okay, and again, I'm going to check if John is here. And let's try to run it in yet another tab, and then I will explain to you what I'm doing. Right, okay. So what I'm doing now is I no longer use the annotations. Okay, I decided, okay, I'm going to control the life cycle of these containers with these fingers, right? Because I have 10. Yeah, I'm not in the sawmill industry. Again, okay, so I have a static block. See, difference. I have a static block, and this should be run only once for this class, right? And then I start the container here and here, and then I go for startables deep start. So basically, it means I could also go for a parallel stream, actually. Right. Only this startables comes with test containers, but you're also good to go with stream off and for each run generate container start. That will also do the trick. Basically, I don't want to forget that I have to run them in parallel, right? Or start them in parallel or concurrently or whatever. And then everything should be the same. And then I'm running the migrations right before each test. And is John still here? Yeah, John is here. Very nice. And the build is still running. Okay. Okay. Right. I don't know. Maybe I shouldn't give. Okay. I have a nice joke. It's really in Polish, jokes aren't bad. In Polish, jokes are dry. Like when you tell somebody a dry joke, then they call water. Basically, because it's so dry. So it says, I'm afraid for the calendar, its days are numbered. And it's really time for you. Someone should tell us a good dad joke. Or what do people do at work when you're compiling or waiting for a build to finish? Drinking coffee. Okay, but I don't have a coffee machine here. Sorry, I will complain to the organizers that there are no coffee machines in the cinema rooms, right? Do you know why I'm looking for a new diet? Because I have a lot of my plate. Yeah, that's a good one. You'll have more. Wave at me because I didn't see you. Wave at me. Okay, I throw, you try to catch, okay? If we don't make it, we'll try. Almost. Almost. Okay. Build success. Very nice. So again, we shaved a few more seconds, okay? Because this time we are not starting the containers over and over. If we, let me scroll up really fast. Now we're starting the containers only once, right? And then we don't start them over and over again. But do you see a recurring pattern or a theme in this log? Yeah, it's liquid base, it's liquid base, it's liquid base, and liquid base. And let me ask you this question. How frequently does it happen that when you're running your tests, between the test cases, the schema of the database changes? Probably never. Exactly. The data can change between tests and tests because you might have different test sets, especially if you have these big monolithic applications, right? And you're testing service A and then service B, and they require different data in database, right? So then you can have different data sets, but the schema, I dare to say, more or less stays the same. So maybe instead of running liquid base or database migrations before every test, maybe we can try to run it just once, okay? Let's give it a spin. In the meantime, I will try to explain to you what's the change this time. So the change is this. I'm checking, and I have files. Basically, here I'm checking, like saying, is the cache hot? Okay, because what I'm doing here, and maybe it's not like a good approach, or maybe it is, I don't know. I here have these liquid-based migrations. Yeah? This is tiny, you see, only 2 of them. Okay, and what I can say is just go and check for these test resources SQL if you have any files in there. Let me see if I have any files in there. Reload from disk. And now I have files in here, right? And I have this new schema and old schema. They appeared. And maybe I should check them into my repository. Maybe I shouldn't. Because, as you know, it's one of these 2 IT problems being cache invalidation. Think of these files as if they were cache, right? So now I'm going into this base integration test of mine, and I'm checking if these files are there. Let's say they're not here. So then what I do, I start the containers just like I did before, right? And then I run the migrations just as I did before, only then I snapshot the databases, okay? So inside the container, I just go for a new container, an old container, I just go and say, hey, run MySQL dump for the user of this container, right? Of course, this password, you don't do that, but it's just only for testing, right? And then this is the path of the container, so we should store this file here, right? And we add drop database, we compact it, and we list that it's only this database, so we don't touch the system schema, right? And then we run it, and so see, this is the result, because I can execute in container. Basically, I can execute in container whatever I please. It's like SSHing into the container, right? Or going into like, this container run IT bash and then calling stuff. So this is the equivalent. So this command generates me a file in here, right? And I check if the exit code is 0. If it's 0, it's good. It means the dump was successful. And then what I say from the container, it should also be this path in container. See, it's a mistake. And then I say copy it back to my machine, which is when I call this method. It's here. It's like schema of the new database and schema of the old database, because fun fact, they are different, right? And then when we go back, so I have this snapshot. So this is what I do when I don't have the snapshot. And when I have the snapshot, then I go and I say this. Create me like this database in database only now with copy file to container. You remember how we were copying jar files into the container in the previous example? So now I'm copying this new schema to TMP schema, and here schema old to this schema again, right? And I'm copying it there, and I say, again, deep start. So this is for the happy path, sort of. The cache is there. The cache is hot, right? And then, so I do it only once, you see, again, in this static block. And then, before each test, what I do, I basically say run SQL, which is this TMP schema SQL. So I go to inside the database container, and now because of this pesky redirect, I have to call shell and say shell, hey, shell, execute this command, so run MySQL, this is the user, this is the password, this is the database, and run this script, okay? So now before each test, I'm only running a script. And again, I check if the execution code is this. And there are also other approaches. The other approach is, for example, you can have a stored procedure that will clean all the data in your tables, right? That's another approach. Or like I said, you can have like a new schema per test. That's also doable. I mean, there are different ways. The whole idea is run the migrations only once, capture the state of the database, and then restore the state of the database. If you're really into Docker, you can go for snapshots and whatnot, right? That's also another approach. Yeah, but I think we have this build finished, and now it says 2 minutes 18. Progress. And you may say, and you may say, was it really worth it? I mean, come on. It's like 32 versus 18. It's like only how many? In memory, like 14 seconds. And you may say, it's not worth it. Okay, how big is your changelog set? Is it only 2 damn files? Sorry, 2 small files? See, this is tiny. This is just creating table, right? This is a creating table, single employees table with 3 fields, and this is adding 2 inserts, basically. And just by not doing this every time, I save 14 seconds. And imagine I have this like 50 changes, 70 changes, or even more. How many changes do you have? Do you have like 20-something changes? Okay, who has like 50 changes? C. Who has like 70 and more? C? So now think, for these 2 changes, I saved 14 seconds. Right, and this grows, and this is it, right? Why doing it over and over again when you can do it just once? And then basically say, database, like restore your state. That's it. Okay, so we shall go for another task, and the task is, what should we actually start with before we start improving things? And this is not only about tests, and the answer is here, establish baseline. Maybe we should have started with this thing, right? So let me run yet another test suite, and I'll be talking in the meantime, right? So, when you have this situation that you have to improve the performance of your system, of any system, what do? Sorry? Yes, we have to measure. Again, yeah, we have to measure, like, if I change this, what I think is an improvement, did it really improve things, right? What did it improve? By how much did it improve? You just don't toss a few monkeys and hope that they will give you Shakespeare like a Hamlet or whatever at the end of the day, right? You have to do it the scientific approach. Like for every experiment, you capture the initial state, right? You have to try to improve things. You have to then check it. Of course, you have to have like some samples that are like not affecting, like just they give placebo to people when they test new medicines and whatnot, right? Because this is like engineering. And it's closer to science than to religion, right? So we don't take things by faith. We have to just have to understand them. So the other thing is, and that keeps me amazed, you know, I had a great job, because for like 6 months or something, I was actually profiling CI/CD pipelines, and I love this thing, really. How often, or where was the last time you profiled your CI/CD pipeline? Few hands. Okay. Just a few hands I see over there. I think, yeah. Peace. For everybody else, you should also profile with CI/CD pipeline, and it's really easy. I'll show you that. It's not a big magic. What you have to do is, for example, start using JFR unit, right? Extension. JFR JUnit extension or Java Flight Recorder. It's like a low overhead profiler for Java. Basically, JFR works like this. That it's like this black box in an airplane. And by the way, these black boxes are orange. So when there's the unfortunate event that the plane crashes, they recover this and unmount it and look for the tapes and whatnot and try to see what happened to the airplane during, for example, last half an hour before it crashed. Okay, so this is the same idea with Java Flight Recorder. We record how our JVM process is behaving, and after it stops, we can open it. We can open this orange box and see what's actually inside. Okay, and you don't have to like do it from the beginning to the end. There are different techniques. You can like start the like profiling in the meantime and whatnot. But here I decided to go for something like this. So I'm going for, you see this JUnit platform JFR, which means that JUnit will start emitting events, okay? Like we will know how long each test has taken and whatnot. And then I have to tune a little bit my Surefire, and I say start flight recording to disk, and this is the file name. So I say recording maximum size 2 days. Of course, it's not going to be 2 days. And path to GC roots. And I have to use this as well because technology quirks. And nevertheless, it gives me it creates. It creates just one file. It's called recording, right? I have many here because I was preparing for this presentation, so I have these results cached. And then you have these files, right? And of course, you have to download them, or if you're using Java 21, you can go for a JFR view command, JCMD, but that's another story. Let's say we have this JFR file, and we have to basically have it as a built artifact. So we download it from GitHub Actions or from your Jenkins or whatever, right? And then you open it in Java Mission Control, and it looks like this, right? You can go for these, like environment variables, for example. You can see what were the environment variables. You can go for system properties, right? You see I'm running like Java 21 and so on, which is Graal in my case, as we can see. And then I go for the recording. Recording is a very nice task because it tells you when the thing started and when did it finish. So as you can see, I didn't run it today. I'm also running it today, but I'm using like the previous examples. And the whole build was taking 2 minutes and 16 seconds. Because it's nice because I can analyze the builds that happened, for example, before the weekend, right? And you can see you see that the build started to degrade, and you can have these recordings, and they're not very expensive. And then you go for processes. And what you see in processes here in these, and I don't know how to zoom this in. Sorry, if the operators can zoom this in, they will do. I can't. I don't know why. It's sort of this Eclipse thingy, and I don't have like Josh Long, this zoom thingy. I'm not using Mac, okay? But you see here a chart. So this is a time when the tests are running, right? And you have this orangish part, and this is the overall CPU consumption, okay? And this barely seen here, like violet or purple part, is the CPU consumption of the JVM process or the Java process, right? So as you can see, we have what color dominates this chart? Who said white? Exactly. You get both. This is where the actual profiling starts, okay? You realize that the dominating color here, sorry, I will deliver to you personally because it's a hell of an answer. Thank you very much, sir. Yeah. The color that dominates this is white. You don't want white because when you pay for CI for the cloud providers, you pay this, okay? You don't pay for, we used a little and the rest was white, so we shouldn't charge us for white part, right? And if I change my color scheme, it would be dark or whatever color you have, but this is let's say, the empty part, okay? I don't want to pay for the empty part and say, okay, you're charged by the minute or by the second. So what do we want to do? We want to squeeze this thing so it grows up, right? Just like with profiling any other system. Think of it, this is batch processing. From certain angle it is, right? You have a batch of tests to process, and you don't want this to be like a little over time. You just want to tackle this stuff, but occupy the CPU as much as we can. This is what we want to do. That's why we should be into profiling in general, in production, but also like, think of it, this is the production of your CI/CD, right? And we just profiling it. So, what should we do? Let me check if the build finished. The build finished, and it's not faster. Why it's not faster? Because the only thing I added is creating this this recording. See, it was recorded. Sorry? Run tests in parallel? Yes, we're going to run tests in parallel. Catch, sorry, yes. We're going to run tests in parallel, which is task number 7. So now we have the knowledge. We've realized that there's this empty part, right, in our chart, and we want to do something about it. And the way we can do something about it is this. Let me check out this revision. Okay, and now you see I've added this, which is surefire fork number. Does it ring a bell? I can run many forks, right? Because let's say I have CPU to consume. Okay, so I want to run for more, and let me just go and look for the README. Where are you? README, manual. Okay, I was afraid that manual isn't here. Let me just go and see if I can run it for 4 forks. Will my machine be able to squeeze it in? And I can now go, if I have access to it, like sort of live, let's go for htop. Okay, and as you can see, now I seem to have more and more load on my cores, right? I have 8 real cores, 16 virtual, so I'm still not using them to the super extent. Why is that? That the obvious reason and the naive answer is I have 4 integration test cases, right? So if I parallel them with the 4 count by each class, of course the other workers will be starving because there's nothing more. So maybe I should like parallelize them in a different approach, right? Maven and Gradle can do that for you. You can read their manuals and they will tell you. Or I can if I have sophisticated test cases, like many of them, I can go for many of them, right? And split them in a different approach. Yes. So basically, this is it. But the other answer is I sort of figure out. I'm saving us some time that this is the sweet spot. Okay. And why is it the sweet spot? Because now see what happens. See what happens. I am now starting, how do I increase? Like this, yes. See, now I'm starting creating container for 5.7 once, twice, 3, 4 times, right? It's because each fork starts its own MySQL 5.7 and each fork starts its own MySQL 8.1. So I'm starting, I don't know if it's still running, Docker PS, it's already gone. But if I made it on time, you would see 8 containers. And starting, what does it mean to start 8 containers at the same time? It basically means that I have to wait for all 8 of them to be available. And then, as you can see, the times naturally increase. So instead of waiting like 15 seconds, I'm waiting for 22. And instead of waiting for like 20-something or 30-something, I'm waiting for, like 50 seconds, right? Because I'm putting more load on my CPU. So when I went for having just 2 forks, then see this recording is no 2 minutes and 16, but 1 minute and 52. So it's like 8 plus 16, how many? 24 seconds faster, right? And let's take a look at the processes. And you see the processes were already looking better. And what you can see here, because there's one of the 2 recordings, so this violet part is not all JVM processes, but it's one JVM process. The other, and all the containers, and of course operating system and IDE, and even running slides, whatnot, is this orange part. But when you compare this and this, you see, this is what I started to do. I start to squeeze it horizontally, so it grows vertically, okay? And then, when I go for 4 forks, like 4 concurrent runners, okay, just like I did. The recording time was at the time, 1 minute 28 seconds. So it was faster than this one, but let's take a look at the processes. Wow, it's looking even better. See, I squeeze it and it grows this way, okay? Spare me the office joke. Yes. And maybe I could continue this approach if I had more test cases, or maybe it wouldn't make that much sense because the more I squeeze it, the more time it takes for individual container to start because they all start at this peak. We all see this peak, right? And then maybe I have so little tests for every container that it doesn't make much sense. So again, I can't tell you what's the correct number of forks. I don't know your machines when you're running them. If it's like a, I don't know, beefy machine in your basement or attic when you're running Jenkins, because they're always in basement or attic, right? We never keep them in close to our desks because they're always like loud and hot. You are smiling, you know what I'm saying about. Yes. So you should run this experiment. You should figure out, like by taking a look at your tests, how much can you squeeze them. And then you can do, maybe I shouldn't, but I'm so tempted because I worked on the thing for like a year and a half, if not longer. What's the approach? Like when you have a problem with something, right? In general, in life, what can you do with this problem? Make it somebody else's problem, right? This is what managers do. They delegate, like, oh, I was called by my boss the other day, and I think, Piotr, that you should be doing this and this, right? Or I get fired, right? Okay, they never say that. They're lovely people, the managers of ours. So, what I can do, let's take a look how this run performed. So see, the container started for longer, but we went to 1 minute 27. And what was the previous time? 2:18. Right? See, we didn't even have this much overhead from this Java flight recorder. So from 2:18, we went to, sorry, not this, to 1 minute, 1.5 minutes, right? So we improved by 50 seconds. But we paid the penalty of the container starting so long. So what I can do, I can go and start it. It's called Testcontainers Desktop. And you can use it for your I'm not quite sure. You will have to ask people at Atomic Jar's booth once they set up their booth, like tomorrow or whenever they set it up, right? And they will tell you everything about it. You can run the containers locally. You can run the containers in the cloud. Let me just, once we are talking to have comparable results, do one more thing because I have my images pulled, and let me go and say, sorry. Where are these? Sorry, SRCCI test resources. Yeah. In the meantime, what does it do? It's part of the commercial offering, I guess. But it's like this is one of the example. In general, the idea is you may run Docker somewhere else. Okay. So when you get this orange part in here, it's because it's mostly the containers. You get them out from this orange part, right? The containers are running somewhere else on somebody else's machine, or it can be your machine, but it's like, let's say, different machine. Okay, so this is how you can squeeze things even more. Yeah, I think I've started it. I pre-warmed it a little bit, and now let's try to run it. Yes. Here, just to keep these tabs. Let's try to run it again with 4 forks. And now let's see how the CPU is looking. So see, everything went red, but now it's going down, 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 down. And why is it going down? Because the containers have started and so on. So as you can see, I got very nice startup times of these containers because now they're not using my infra, but I'm using somebody else's infra. So I'm not waiting like 40 seconds or 50 seconds for this container to start. I'd wait only 10 because, fun fact, I made like each pair of the containers run in their machine, right? It's called like a turbo mode or whatever. So this is one of the approaches. You basically the lesson is this: offload your containers somewhere else. So they are not like competing with your test for the CPU and the resources. They can be running somewhere else perfectly fine if you are just into shrinking or making this thing faster. And the thing is, we have 26 seconds. Did I hear some wow over there? Maybe. Yes. And this is like, I also captured this recording, and this is how it looks like or may look like. See, it's this. It's huge kaboom. Poof. Right? And it's shortened, and then it's even less of this orange pie because this orange is like running in the cloud now. I made it somebody else's problem, right? And then it's like up to your budgets, up to your platform operators, up to your admins or managers. Like, how can we organize our builds so that the containers are running on a different machine, okay? And then the Docker is available to the machine when I'm running the test. Okay, let me stop it. That was enough. And okay, 26 seconds. Maybe we can still try doing something about it. I happen to run Linux machine, which is okay. Let me create a new tab and zoom it in. And it's important because I have Linux machine, right? And I'm going to go for the last thing. Sorry, where is it? Oopsies. Sorry. See, I'm still stressed. Not this, you dummy. This. So the last task is this. No Kubernetes this time. Remember always these three? So we tackled CPU already because we said like these fork numbers. We tackled network because instead of running the database migration over and over, sending it over the wire again, we just told the container snapshot it, and just then we sent like a little ping message, hey, restore yourself. Hey, restore yourself. This is what we do, right? And now maybe it's like, let's take a look at this htop. In general, as you can see, I have loads of RAM. Yeah, you're envious. Very good, you're envious. Right? That's why you should get like yourself like a beefy Linux machine. Yeah, but maybe we can use this thing. Maybe we can take benefit that I have so much RAM, like my CI machine could have, and let's go for the last answer for all these improvements. And yeah, so we are here, and now let me run the test for the last time. Again with four forks. And what I'm doing here now is basically this. Now, when I build these images, I say with temp file system. And it works on as far as I can tell, on Linux only. And what I'm saying is that make this thing like a temporal file system, read, write. I mean, this is the path inside the container, right? When you start these containers, I should have, there's like a doc page. It explains how it works, and they have a nice thing. See, so instead of like mounting a volume on the host, I'm sort of like mounting like part of the file system, so it maps to my host's memory, more or less. This is how it, like, it's oversimplified, but this is how it works, more or less, right? And then it's 20 seconds, right? And you are now thinking, no way. This is some kind of sorcery, right? He must have changed something. He cheated. For sure, he cheated. It's impossible. And at the beginning of this talk, or this part, I promised you I won't be touching the actual integration tests. But guess what? I used to work as a team leader as well, and I lied. Now, instead of running just 1, 2, 3 tests for each test case, I'm running 15. So instead of 3 tests, I'm running 15. I smuggled it in one of the Git updates. So we went down from 10 minutes to 20 seconds, and we're running 5 times as more tests. And if this is not a reason for an audience to give a very nice applause, I don't know what is. Thank you very much. So I guess it should be more or less like this. When you go to work to your manager on Monday after this talk, and they say, so I know that you've been to this Testcontainers talk. I know that you brought us some stickers, right? But really, we can't run these tests because they are too costly. Then you can answer, I'm afraid, boss, this is not true, because we can do a certain things, right? And we can improve the duration of our integration test suite. We can get from quarters, from half an hour or something, we can get into like sub-minute time. It's possible, it's doable, right? It just requires that we step over shooting the messenger, okay? Because if you think about it, test containers, it's only, right, a Docker wrapper. And then you have to like apply all of your sysops knowledge, platform ops knowledge, or so on, right? So what we should do, in a quick recap, split fast and slow tests, okay? If you really have to keep them in one bag, okay, fine. But then don't pick them together at the same time. Pick fast, then pick slow test, okay? Measure, improve, or try to improve, measure again. Okay, make sure that you're not like downgrading your performance or something. Don't do random changes. Just measure it. This applies for like this step for every platform or system optimization. Okay, avoid unnecessary work. Okay, don't do something if you don't have to do something. If you don't have to start, this melts nicely with the next one. Do something once and not again and again. Right? Don't start container for every test. Don't even start it for every test case. Just start it once, okay? Stop doing it over and over again. Doing something once is usually much faster than doing something many times, okay? And then, when you have resources, RAM, CPU, parallelize to the max, okay? As much as you can squeeze. I could easily go for 8 forks or something. It would still work, provided I would have enough tests, right? I would split this 60 tests into like different test cases. But then there will be congestion, basically. So we have to find this sweet spot, right, for your like the configuration, what it makes sense to run it or not. A few more pro tips for you, if you will. Use modules. Do you know what test containers modules are? Okay. Who knows how to run Kafka? So we can blindfold it. Okay, keep it up. So I assume you can blindfold it, or maybe you can take a look at the keyboard. You can type everything, every system variable, every command, zookeeper, if you still use old version. Okay, hands down. It's still up. Because you know it. Okay, you know it because you're a troll from Estonia. Okay. Yes. So this is, if you basically don't know it, right, you can go and use modules. Right, and these are these, right? So as you can see, when I was building this generic thing, I used generic container, okay? But then when I was using MySQL container, right? I added one more dependency, which is this thing. So test containers MySQL, right? It basically says that now I want to use MySQL. And it does this whole system variables, listening for ports, waiting for whatever has to appear. I don't know whether it's like select one or a port open or whatnot, right? And so as you can see, there's a number of technologies. And I have my favorites here. I'm not going to lie. There are these like databases. There's like Nginx, message brokers. There's Selenium. There should be WireMock, which Oleg will cover in a few days, right? And so on. Yes. And what's also important is these official modules. And, well, usually batchers tell you don't eat the sausage, right? Because they know how the sausage is made. I've seen how this sausage is made, and I can tell you, eat this sausage. Because what does it mean that it's an official module? It means that it's not only volunteers, right, from the community. It's not only, how they say it, people employed to work on test containers, right? But it's actually also people who work on this thing that's being used in this module. So, for example, when there's, just random example, Neo4j release, okay? And something doesn't work and so on, then there is like, and I really know it because I know how the sausage is made, there is like a common Slack channel, right? And Neo4j people talk to Testcontainers people, and vice versa, and therefore you can get the best of these two worlds in Neo4j or Neo4j Wiremark or whatnot. So these official modules are especially very, very nice, right? So you go for these modules. What else do you do? You consider using framework integration, okay? So Quarkus and Micronaut were doing this for quite a long time, and Spring Boot. Are you using Spring Boot 2 something? Are you using Spring Boot 3.0? Are you using Spring Boot 3.1? Okay, so I'll give you a reason to go for Spring Boot 3.1. I'm not gonna run this code. Don't have that much time. Again, what is possible? Let me zoom this a little bit here. Also, I can't compete. I mean, I already used Graal. Why should I compete with Alina and Josh Moore? It's basically like this. So before Spring Boot 3.1, if I'm not mistaken, and if you were, for example, last year to Kevin's and my workshop, we were using this initializer. So you start the containers manually, and then you have to tell Spring in this dynamic properties loader or whatever it's called, loader, bin, manager, factory proxy, that, hey, you can reach Kafka, PostgreSQL, MySQL, Cassandra, Redis using these properties, right? Because you don't have properties file. So you have to do it dynamically. And now we don't have to go for this with Spring Boot 3.1 because when I have this application, sorry, I went up too much. Let me go back. Come on. Yes. Now what I can have is like I have in my test set, of course, I can have test application, which is Spring application from my actual application, right? And I have something like this. And what I add there is I can have my containers configuration, and I just say over these containers when I have like a method that generate me beans, I also say service connection, right? And this is enough when you run this with this containers configuration for Spring to figure out, hey, he's actually using Neo4j container. So I will use it in this test application of mine, right, in this thingy. So this poor person doesn't have to like start these containers manually and inject back, like how do I call them, how do I use them, and so on. This is what you do, right? If you use something that can't use this, what's it called, service bean, because like it's not yet integrated, or you still want to do it more of like manually, you can do that like it's here with this MongoDB container, right? This thing. You start it, and then you tell Spring back, hey, this is like the good host and the port. Again, see, I'm not using localhost. Remember this, please. More slides. Don't fix ports, okay? Because there are reasons still, for example, the most obvious reason, if you still have Jenkins and you have like 2 concurrent builds and everyone wants to have PostgreSQL running on port 5432, guess what? One build will get this port, the other won't, right? Or when we go for this fork mode, right? You need to have random ports because how else? So basically fixing ports, it's a recipe for a disaster. Again, start the containers once and start them in parallel, unless you really have to run them, like restart them like I had to for this smoke detector, right? And maybe, as I have shown you with this Graal image, maybe you can reuse, okay? So maybe you don't have to, this is useful especially on developers' machine. When you have this one class, or this one integration test class, right? And it starts only these 2 containers. You don't have to like start them over and over again. You can start them and keep them running on your machine. And when you basically log out or go for like Docker stop manually, then you have to like then a Ryuk won't take care of them, and you have to stop them manually. I don't know. We still have a few minutes, so let me. Because I competed with Alina and Josh, and it wouldn't be fair if I didn't compete with Nikolai. So let me show you one more thing. It's for this chaos engineering. Let me exit this presentation mode, and to show you like what fine, nasty things you can do with test containers, and that's why I use it for my other demos, for example. So, virtual threads. What should you use virtual threads for? You don't know because you haven't been to Nikolai's talk. Very nice. So I tell you, you should use them especially for I/O, okay, for blocking operation, because when you have a virtual thread, then it will unmount the platform thread it's using, right? And then the platform thread will go for some other and drive your virtual thread. And what you don't want to use them for is I/O inside synchronized blocks, because what it does, it's pinning virtual thread to the underhood or carrier thread, okay? So you don't want to call I/O operations lasting 20 milliseconds or more, because then you downgrade your virtual threads experience, okay? I spoiled it, sorry. And maybe we can test it, okay? So how can I test it? I have my service, right? And again, I'm packing my service into a container, and then this service is about to call another service over the internet, okay? And how do I make sure it's like, let's say half a second delay in this network calls, okay? I can do that. I mean, this kind of chaos engineering or stress testing or whatever with test containers. So what I do, again, is I'm going to first create, how do I do that? Like this. I'm gonna start 2 containers. So one container is Nginx container, and I copy there my index file, which I have here, right? And this is how I start Nginx container. And see, I sort of lame because I don't start them in parallel. Oh, no, actually I do. See, I start them in a parallel in a stream. So I create Nginx container, and I create Toxi proxy container. It's a lovely module. If you need to test your stuff, how it behaves in a unperforming network, you go for Toxi proxy, really. And then I start these containers, and I say I want to have latency plus jitter, of course, when I'm going to call this Nginx container over, or Nginx server running in container over Toxi proxy. I want to have like more or less half a second delay, right? This is what I want to have programmatically in my test, and then I pack it just like I did my test detector, right? Smoke detector. I put this stuff into the container, right? And then I run it. I figure out where to call it, right? I start it. I figure out how to call it, and then I do this thing. I go. This is important, right? This is important. I say JDK trace pin threads 4. And what does it do? Whenever I'm pinning a virtual thread, okay, meaning calling I/O operation inside virtual thread for longer than 20 milliseconds because it's synchronized block or synchronized methods, then it's gonna print me full stack trace and tell me, hey, this is where like things aren't working okay. So let me run this thing. Yes. Again, in a similar fashion. This is what it should do. Come on, and let's see if it's... I don't know. Why? It suggests I should go for Kubernetes. I don't know. See, so it's created this Toxi proxy, which is like a network, like in between. Yeah, and apparently it didn't work. This result is maybe not so nice to see, so let me go for this thing, and let's debug it. We should be able to see it. Okay, yes. Yeah, come on. What is this? Oh, not you. Come on, it's like another demo. This thing. Sorry. Right. It's not finalizers. But the long story short, you shouldn't be using finalizers, right? Okay, here's like a parking. See, I was debugging this virtual threads thingy. Okay, and I'm here, and I can go for, I have this result, and I have this, and this is my stack trace. Because my system, which is using virtual threads, when it connects to this Nginx, it just says that I created or received an answer, right? And when I pin it, I can see that because of this JDK trace pin thread set to full, I can see where is it pinned, and it tells me if I scroll this, oh, it says here, see? It says I'm pinning my virtual threads in greetings obtainer in line 29. Okay, so I'm misusing virtual threads. So now let's go to, sorry, how do I go there? Greeting obtainer, line 29. I'm pinning it here. Yeah, I'm going for network operation, client send, and guess what? I'm in a synchronized method. So and this is like if you do only like mock testing, or even if you run your containers locally and it's like fing, 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 you're not going to notice it. Unless you go for toxic proxy, create like a intoxicated network, and then you can see such things. So thanks to test containers and other technologies, of course, you can even programmatically set a receipt for disaster. Stress test your application if it's behaving correctly, because if that was the case, I wouldn't be able to run more than 16 requests, okay? Because these virtual threads would be draining my like carrier pool, which is 16 or 32, I don't know. It depends on your CPU. I forgot what's on my machine, sorry. So let's say I went here, I fixed this. If you really need to log something, go for a re-entered log, for example, okay? Synchronize it performance-wise is also not nice in this example. And now let me go for this test again. And let's see if this time I'll be pinning my virtual threads or not. Okay, maybe they are pinned in some other place. Because what they tell you is like, go for virtual threads everywhere. Except maybe you have these corner cases, or I hope not, the main flow cases, when you're going to misuse virtual threads in your system, and then you're actually going to downgrade the performance of your system, right? This time, as you can see, the build was successful, and as you can see, there were these attempts from these 20 runners, because the whole test is like, run this or get this greeting 20 times. And you can see I've made 20 requests over this intoxicated network, and none of the virtual threads was pinned, right? So this is how it went. Okay, now, yeah, sorry, last pro tip. Avoid network round trips in before each, okay? It's not a good idea. That's why we didn't have these liquid-based migrations, or we move them away from before each. Even we don't copy the script or the dump in before each. I just copy and create it once in situ, right, in place in this container, and all I'm doing in this before each, I'm saying like, hey, now it's your time to run, okay? And you can call like stored procedures like this and other stuff, or create schemas, whatever. Now, we are almost at the end of the presentation. I kindly remind you that I still have like the stickers for you if you fancy them. And now, this is the important part of every meetup, of every conference, every talk, and so on. So always for everyone, for every speaker, for every talk, just for the organizers. And it's also for future use, so you can get like better stuff next time, right? So I would kindly advise you, ask you, to do it every time, and for everyone, just provide your feedback. And now it's the time for you, I guess, and please do that after every talk, like you have this badge here, right? And it says that you can go and vote for the talk. So I hope you like this talk, that I was able to show you how we can use this technology to be that much reliable. And I also hope I've proven to you that you can get, without that much effort, from 10 minutes builds to sub-minute builds, right? If you didn't like something, I would appreciate if you could tell me what was the thing you didn't like, because I would love to improve, right, this presentation, my skills in general, and our life. This is the reason, the motivation why I'm doing this talk, right? So I can infect you, fellow developers, that our lives can be better, that we can sleep better, that we can have more confidence, right, on Friday evenings or during weekends, that nobody will call us because we've tested our system really, really good. So please provide your feedback. And I guess there's also product placement. Yeah, sorry. If you're watching this later on YouTube, right, do two things, please. First, don't forget to subscribe and hit the bell button. And also, you can. I don't know in which corner this will end up, so please go and fill this anonymous survey. I would really appreciate that because I also like to know what it was for YouTube speakers. Attendees or like viewers. If you prefer this form over DevOps form for whatever reason, you can also do that, of course. And this is the time for the product placement, which is me, or not me directly. I'm not offering myself as a slave. But if you like this presentation, if you think your organization or company can benefit from your skills, from my skills, sorry, and from yours, of course. I can be hired like a permanent contract or a full-time job, or even for like consulting or training, right? So hire me. If you think that wasn't enough, if you still would love to follow me on Mastodon or Twitter, I'm also on Blue Sky and LinkedIn, because you would love to have more Java insights, more dad jokes, or basically poor life advices. I'm here ready to be followed. And with just 2 or 1 minutes left, I think this is it. These are the slides. Okay, so these are the slides, and then inside the link to code and everything. This is it for you. Thank you very much.